hate when I get guys like you.
Is it 16 by 16 or 14?
Yeah, it was the same digital receptor.
They still miss you with the 16 by 16, so they missed the bottom part of it.
Oh, yeah, the costophrenic angles were kind of like sticking to the side.
How about the sides of the lungs? Did they clip off the side of the lungs?
It started to clip the sides off like 2/3 of the way down.
So they end up having to use both images.
Yeah, she was like, yeah, it's okay, we can see it.
That's always a response. It's okay.
It's all right.
We'll just piece it together. It's good.
Yeah. All right. So again, thoracolumbar spine is demonstrated to demonstrate the convexity or concavity of the spine. All right. It's good for demonstrating spondylolisthesis and degree of kyphosis and also lordosis.
So this one is just one shot. It's not the two shot.
One shot. Yeah. All right. What's going on with her neck?
Yeah. That's an old
I
lady.
just noticed that too.
That's a little old lady right there.
Yeah, that looks pretty bad.
That's grandma right there.
So why is it called a scoliosis series? These aren't.
It's called scoliosis series only because it, when you have scoliosis, it's not only going to be side curve, but there's going to be a rotational curve too. So they're trying to see the degree of rotation of the spine.
Is it always you get the rotation?
Depends on the severity, not always. So you can just have the curvature without rotation. For those that are severely severe curvature, it may also involve a twisting or rotation of the spinal column. That's common for severe cases.
Does that have a name or is that just scoliosis?
It's just part of the scoliosis. Oh, the twisting, I don't know. Okay. This is the Ferguson method for scoliosis series. What they're doing here is they're trying to differentiate between a deforming curve and a true compensatory curve. Two images are required. One is just a normal standard AP or PA. Okay, the criteria is the same. Large image receptor with the bottom of the image receptor 1 to 2 inches below the crest. So the first one will be done standard AP or PA. The second one now, they're going to place a bolster under the underneath the convex side. Okay, and the convex is the lateral curve in which it curves out. So this curves out to the left of the patient, so they'll be putting a bolster underneath the feet to try to straighten it out on the left side. It can also be done sitting down, where instead of it being placed underneath the feet, it's going to be placed underneath one of the butt cheeks, one of the buttocks. Okay? So two images are obtained, one standard and the other one will be elevated on the convex side with a block or some kind of bolster underneath the buttock. Okay? Questions? So again, this is done to differentiate between the deforming curve and a natural compensatory curve. All right, so here we have two images comparing the two, one with a lift, the other one with no lift, the other one with a lift. And you can tell, again, they're just looking for alignment. This patient's wearing a bra, they don't care. We have a bra, we're just looking at alignment. We're not looking for detail, we're not looking for resolution, we're looking for alignment. Okay. All right. Next one here is right and left bending. Right and left bending. This may be done with conjunction with the scoliosis studies. So what this does is that it demonstrates the range of motion. So everything stays the same. Large image receptor, bottom of the image receptor 1 and 2 inches below. We're going to put them right in the middle of the image receptor, and from there you have them bend as far as they can on either side. It is done for comparison, so you do a right and then you do a left. The pelvis has to stay within the middle that acts as your fulcrum. So when they're bending, make sure that their hip isn't doing this. Okay? It doesn't go off to the side. When you bend them, it has to stay in place. Okay? It acts as your fulcrum. Now, this is one of the situations where you don't call them into the area of interest because now their orientation is going in a diagonal way. So we want to open up our image receptor, our field to the size of the image receptor. Okay? All right, so right and left bending. open up to the size of the image receptor. It is to demonstrate motion. Okay, questions here? Let's keep on going. Okay, lateral hyperflexion and hyperextension. This is also done with two images, comparing the two. Same criteria of positioning your image receptor. Center is going to be at the mid-coronal plane. Just like in the bending, hyperflexion and hyperextension, you're going to keep the pelvis as your fulcrum, making sure the pelvis doesn't move during these positions. So this demonstrates mobility at the fusion site. Right and left bending may be part also of this series, also done on expiration. What's funny is when I was looking at this, I don't know why they just didn't use the same model. Once they're two different models.
Mm-hmm.
All right, any questions here? So this is for spinal fusion. All right, let's finish this off with sacrum and coccyx. Okay, based on the curvature of the back, if we're doing an AP axial, sacrum we're going to angle towards the head. Tailbone is going to go more posteriorly, so now we've got to angle the other way for the coccyx. Okay, so for an AP axial sacrum, the degree of angulation is going to be 15 degrees cephalad. Okay, so this is going to be half the amount of the L5S1. Because now what we're trying to do is we're trying to get the sacrum in true profile. So 15 degrees cephalad. It's going to be 20 degrees for greater posterior curvature, which applies to the females. So 15 degrees your average. Centroid is going to be between the symphysis pubis and the as is. Do we know how to find the symphysis pubis? Are we going to feel for it?
Yeah. Put your hand all over it. Yeah.
No, you don't want to do that. So what else is at the level of the symphysis pubis?
Your
Okay, the what?
greater
Greater trochanter. Okay, greater trochanter. So you just palpate for that. Also, by bolstering their legs, it will help straighten out the sacrum a little bit better to put it in true profile. Now, this is one of the criteria, and it isn't followed, but it should be that if it's a focused study on the sacrum or the coccyx, there is a prep that is suggested. The bowels have to be empty. Okay, because you have the bowels overlying that area, and fecal material can show up as some kind of anomaly on the bone. So we want to try to get rid of any gas or any type of content in the bowel as well as the bladder. So they got to empty out before you do the shot. Okay. Respiration, all the respiration does, if you suspend respiration, it just prevents any type of movement during the exposure. It's not necessary, but they say to suspend respiration so there is no movement. Okay? Now, if that's for the sacrum, okay, sacrum is not foreshortened. The foramina is going to be well visualized. Okay. We're not seeing tailbone on this, right? Where's the tailbone? Where's the coccyx?
It's like under the symphysis
It's under the
pubis.
symphysis pubis. So this is strictly for the sacrum. We're not going to see this. So if we want to visualize this, how are we going to visualize the coccyx?
Going caudal.
Now we have to angle it the other way. We're trying to project the symphysis pubis away from the coccyx. So now we're going to do a reverse angle. So for an AP axial coccyx, it's going to be 10-degree angulation towards the feet, greater again for females. Centroid is going to be 2 inches superior to the symphysis pubis. 2 inches superior to the symphysis pubis. Again, we want to make sure they're cleaned out. Okay. Now for males, can we shield males? Obviously we can't do females, but can we shield males?
Mm-hmm.
Yeah. Sure.
Yeah?
This one too, right? Yeah. Okay, now if you notice here, now the coccyx is free from superimposition from the symphysis pubis. It's free and clear. So here we have the coccyx nice and nice and profile, but now you can see that the sacrum has kind of foreshortened a little bit because of the angulation. Okay, collimate to the area of interest. We don't need an open field. All right. Lateral sacrum and coccyx. Now the lateral sacrum and coccyx is usually done as just one unit from sacrum and coccyx. We don't do one separately. They're usually done as one unit. Okay? So it's included in one image. Central ray is 3 to 4 inches posterior to the as is. And again, if possible, use a lead strip. Collimation is important. Minimizing any type of exposure to the patient is important. So when we do a lateral, we include both these, the sacrum and the coccyx. 3 to 4 inches posterior to the as is. Okay? So for a lateral profile sacrum, the notches, this area right here, the notches should be superimposed. Okay? And we want it from top of the sacrum to the bottom of the coccyx. And you want evidence, some evidence of L5. Okay, you want to show some evidence of L5 because we need a starting point. We want to make sure that we've got the entire sacrum on there. And to show that we've got the entire sacrum, you need to include at least a portion of L5. Okay. Now, if the procedure just calls for a coccyx, you're not only going to be 3 to 4 inches posterior to the as is, but you're also going to go 2 inches down. 2 inches down. This is going to require lower KV and mass than the sacrum because we're not shooting through anything but cheeks. Right? You know where your tailbone is, right? You can feel where your tailbone is. It's right between your cheeks.
Sometimes a lot of cheek, though, man.
Yeah. So you're going to decrease your technical factors. Okay. Also, lower KV is going to give us more of a contrasty type of image for better visualization of the coccyx. Okay. So when this is happening, now we don't have evidence. We can't see the top of the sacrum. We're not seeing L5, but we don't care because this is focused just on the tailbone. Okay. So coccyx with open segment and inner spaces are demonstrated, if not fused. Again, we're looking at the greater sciatic notches, okay, making sure that they're superimposed. Collimate, 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 collimate. Okay?
Mm-hmm.
All right, let's just do this real quick. Lateral lumbar spine, what's the problem here?
It's not centered properly.
Okay. Are we cutting anything off?
Yeah, you're getting
Yeah.
the spinous process.
We're missing the processes, okay? Because the processes is part of the vertebrae, so that needs to be included. Okay. But do we have all the way up to L1?
Yeah.
5, 4, 3, 2, 1. We got one, but we're not seeing the spinous process, so we need to center anteriorly or posteriorly?
Anteriorly.
More towards the back, so posteriorly, right? We want to include more of the back. Okay. What about this one?
Ain't taking my belt off, boy.
Yeah, so we got everything going on here. We got the belt, we got the zipper, we've got bra.
It's a bad exposure, too.
Bad exposure is too. Well, this is what I think happened. They phototimed it and they were shooting through this.
Oh.
Yeah, so when they phototimed it, they're shooting through metal and it gave you a longer exposure, making it darker. That's my guess.
Makes sense.
Thank you. I haven't made sense all day. Erect lateral scoliosis. What's going on here? Technique, yeah. It's a little grayish. Are we cutting part of the
Spine off? Yeah.
Yeah, so we're missing this. It's when we're doing a scoliosis studies, we're looking at the relationship between the T-spine and the L-spine. We're missing the T-spine completely, but we've got some legs down here. Are they too low? Yeah, so they need to go up a little bit. How about this one? Identify the most, okay.
Very long.
So yes, I agree, centering, there's some modeling going on.
It's not. It's
It doesn't
over
model area.
rotated.
Over rotated, why do we say it's over rotated?
Because where the eyes at.
Eyes are towards the back. We're not even seeing the eyes here, but I'm sure they're back here somewhere. So that's over rotated. Everybody agree? Okay, let's call it over rotation. How about this one? Identify the most obvious repeatable. I don't even think it's obvious. It's just,
Rotated.
yeah, you can see the Scotties, but where are the eyes?
Like
They're a little bit more
anterior.
Yeah.
Supposed to be AP.
Yeah. We're supposed to see the sky, that's not an oblique.
Oh yeah, it's an
So
AB.
that's an AP.
Oh, it's an AP.
Supposed to be. Yeah.
There should be.
They're oblique. Good thing that's your last
Okay.
slide.
Yeah. This is an AP lumbar, but they're oblique. Thank you. That's obvious.
Done.
That was so obvious.